All right, class, it's time to start a new unit, Unit 4, covering triangles. Today we're going to be doing 4.1, classifying by sides and by angles. There are two parts to this video, so make sure you watch both videos. There will just be one homework though. So classifying by sides, we're classifying triangles, determining what type of triangles these are. So a scalene triangle has no congruent sides, meaning no sides are the same length. They're all different lengths. An isosceles triangle has two congruent sides. So you'll have two side lengths that are the same. And then an equilateral triangle, we've talked about equilateral polygons before. Now we're talking specifically with triangles. All three sides are the same. Equilateral, isosceles, and scalene. So that's how you would classify triangles by sides. Now classifying them by angles, it could be an acute triangle. All three angles would be acute. So it might look like that. All of them would be less than 90 degrees. All angles less than 90 degrees. A right triangle just needs to have one right angle and it will be a right triangle. So if you've got a right angle in there, it is a right triangle. An obtuse triangle has one obtuse angle. So kind of like the same rule with the right triangle. If there's just one obtuse angle in there, it will be an obtuse triangle. And an obtuse angle is an angle more than 90 degrees. So one angle more than 90. An equiangular triangle, we talked about equiangular polygons, so it's same as that. It will be all three angles will be the same. All three angles congruent. And when you have an equiangular triangle, all of the angles will always be 60 degrees. All angles will be 60 degrees in an equiangular triangle. All right, we're going to skip over these first two definitions. They'll be in part 2 and go on to these examples for classifying triangles. So we need to classify these triangles by sides and by angles. So let's do sides first. We look at our sides, we've got a side of 23, 19, and 8. None of them are the same. So it is a scalene triangle. Then if we look at its angles, we have 19, 51, and 110. They're not 60 degrees, they're not equiangular. None of them are 90 degrees, they can't be right. We have an angle of 110, so it has to be obtuse. So this is an obtuse triangle. We'll look at our second triangle and classify by sides. We have sides of 4, 4, and 4 square root 2. So two of the sides are the same, and that is an isosceles. Isosceles triangle. Learn how to spell these because if there are any fill-in-the-blank answers, they'll need to be spelled correctly. So use your notes, make sure you know how to spell them. Classify by angles. We have 45, 45, and 90 degrees. So we've got that 90 degree in there, so we know it is a right triangle. Continuing on, classifying by sides and angles. Here we've got a side of 5, 2.9, 5.8. So that is scalene. They're all different. Then our angles have an angle of 30, 60, and 90. So again, we've got 90 degrees in there. We know it's a right triangle. Then number 2, our sides for number 2, 17, 17, 17, it's equilateral. And then our angles for number 2, we have 60, 60, and 60. Remember I said if all the angles are the same, they will be 60 degrees. That is equiangular. Now if you remember in our polygon unit, anytime we had an equilateral and equiangular polygon, it was known as a regular polygon. So this is a regular triangle. If it gives an option of regular, you would still need to answer that that is a regular triangle. But just by classifying by sides, it would be equilateral. Just by classifying by angles, it would be equiangular. And then our third and final example, classifying by sides, we have 10, 10, and 18. So 2 sides are the same. That's an isosceles triangle. And then classifying by angles. We have 30, 30, and 120. So we have one angle that's more than 90 degrees. It is an obtuse triangle. All right, one more example to work through. We need to classify this triangle by its sides. Well, they don't tell us what the side lengths are. We have to figure that out on our own. And to do that, we're going to have to use the distance formula. We know the points for this triangle, the points of the vertices of this triangle, at -1, 2, 0, 0, and 6, 3. So we can use the distance formula to find all of those lengths. So if I look first at PO, and I'll use P as my x1, y1. So I have -1 minus 0 squared plus 2 minus 0 squared, all under the square root. So I'm dealing with PO here. So then I get 1 plus 4. So that is square root of 5. So PO is the square root of 5. That's its distance. And then if I look at OQ, make this one blue, OQ. Need to find the length of that. I'm going to use Q as my x1, y1. So I have 6 minus 0 squared plus 3 minus 0 squared gives me 36 plus 9. So that is the square root of 45. So my blue line here, its length is square root 45. And then we need to do our other one, QP. That'll be our green line. I will use 6,3Q as our X1, Y1 again. I think it's just easier using the larger numbers because since you're subtracting. So 6 minus -1 becomes 6 plus 1. I'll write it in here so you see what we're plugging in. And then 3 minus 2 squared. So we get 7 squared, which is 49, and 1 squared, which is 1. So 49 plus 1 is 50, so we have the square root of 50 for our third side. So if we're classifying by sides, we look at those sides. Are any of the sides the same? No. So it's a scalene triangle. It is scalene. Now, one other thing I want to look at. If we needed to determine if this was a right triangle. So I'm going to write this up here also. If we need to determine if it's a right triangle, we're actually going to use what we learned in Unit 3. In Unit 3, we talked about parallel and perpendicular lines and the slope of parallel and perpendicular lines, right? Well, perpendicular lines form right angles. So if we can show that the slopes of any of these two lines are perpendicular to one, or any of these three lines are perpendicular to one another, we'll know it's a right triangle, and it'll form a right angle where those two lines meet. So we need to look at square root of 5, that side length. Look at the 2 points. We've got -1, 2, and 0, 0. We need to find the slope between the two, and find the slope between the other two, along the other two lines, and see if any of them are opposite reciprocals of one another. So from O to P, I go up 2 and left 1, so up 2 and -1. So that would be a slope of, so we're dealing with PO's slope is -2 over 1 or 2 over -1. So we get a -2 over 1 for PO's slope. If I look at OQ, still looking at the slope. It goes up 3, right 6, so 3 over 6, which simplifies to 1 over 2. And right there, we have all the information we need. Just from those two, we can see that they are opposite reciprocals of one another. We change the sign. Instead of negative, it becomes positive, and we flip the fraction. It's opposite reciprocal. So we know those two lines are perpendicular to one another, and they will form a right angle. Now, a little hint or trick. I knew to start with the square root of 5 and square root of 45 because they're the smaller, they're the shorter side lengths. In a right triangle, you have 2 legs and a hypotenuse. The hypotenuse is the longest side. It will not be the right angle. You will not have the right angle along the hypotenuse. It'll be along the 2 shorter sides. So the 2 shorter sides will form a right angle if it is a right triangle. So you can use that to eliminate and not have to find the slope of the third line. But you could find the slope of all of them. All right, that's it. End of notes for part 1. Be sure to watch part 2 because we've got 2 notes videos, but just 1 homework.